Okay, so today we continue to learn about probability, and our learning intention today to learn about very powerful way to solve probability problems. It's called tree diagram. Tree diagram. So, what is tree diagram? For example, if we toss a coin, what outcomes we can get when we toss coin? Heads or tail. So when we toss a coin, we can get head, we can get tail. If we toss coin second time, again we can have head, we can have tail.
Other side.
Head, tail, head, tail. What will be the total outcome in this case? Two heads. We get head, head. So if you go this pathway, head, tail, this way tail, head, and tail, tail. So, how in this case we get tail and tail. So we have how many possible outcomes we have?
4.
1, 2, 3, 4.
6.
So, what is the probability? What is the probability of get 2 heads?
1/4.
1 out of 4. Because we have 4 outcomes, only one has 2 heads. What the probability of get 1 head, 1 tail, does matter in which order?
2
2 out of
1
4,
over
which
2,
simplifies to 1/2, which is 1/2. Make sense?
Yep.
Now let's consider if we toss coin third time. If we toss coin third time. Again, when we toss coin third time, we again can have either head or tail. So we continue our tree diagram. And you can see why it's called tree. It's like branches of tree going.
Is this something like theoretically though? Like it doesn't have to be heads and tails.
Why is it heads and tails?
Yeah, like why? Because like we haven't rolled it yet.
Because you can.
Sorry?
But like this is just theoretical though, right? Like we haven't flipped it yet. So how do we know if it's gonna be heads or tails?
No, we don't.
What possible outcomes are?
Heads and tails.
Head and tails. We can have only 2 possible outcomes. What is the probability if it's fair coin? What the probability of get head or get tails?
50%.
1/2.
Yeah.
So that's what we said. It's 2 possible outcomes. It does not mean. It doesn't mean we get probability. For example, you toss 2 coins and we have the probability to get 1 head, 1 tail is 1/2. But it does not mean if you toss 2 coins. But no, we covered all possible outcomes. But if you toss 2 coins, like repeat that experiment 100 times, not necessary that 50 times you will get 1 head, 1 tail. It's not necessary. In long run, that will be our topic of the lesson on Friday, the experimental probability. Yes, you're right, this is theoretical probability.
Yeah.
But in the long run, theoretical probability and experimental, they come in together. Yes?
So with the tree diagram, could you also like, if you did that, then roll the dice? And so for like heads, and then would you do 6?
Yes, we can do, but for the rolling die, because it's 6, it will be like 2 branch out, it's not convenient way. Usually tree diagram, when it's more than 3 possible outcomes, it's not the best way to do it. So we can have head, tail, head, tail, head, tail, head, tail. So what is the total outcome here?
Heads.
3 heads, head, head,
Three
head. Here we have
Head,
head, tail. Head, tail, head,
Head,
Head.
tail.
tail. Tail, head, head. Tail, head, tail. Tail, head, tail, tail. How many outcomes we have?
8.
Eight.
Hey. 29.
I didn't count that.
Just count. 1, 2, 3, 4, 5,
It's
6,
also
7,
double.
8. Yeah,
I was
8.
getting to it.
Very good observation. You see, when we toss one coin, how many outcomes we have? Two. When we toss two coins, we have four. When we toss three coins, we have 8. If you will toss 4 coins, how many outcomes?
12.
We'll have 16.
Oh,
It doubles every time.
damn it.
Doubles every time. So, now what will be probability of get 2 heads? Let's count how many we have. 1, 2,
Oh,
3. We had 3 outcomes with 2
3 out of
heads.
8.
Will be 3 out of 8. What will be probability of get 3 tails?
1 over 8.
1 over 8. 1/8.
This is only one time when that happens.
Sorry?
For the one with 2 heads, could you include the top one as well? Because it gets 2 heads in it. It just has an extra one.
Very good question, but then this is if to get exactly 2 heads.
Oh.
If question will ask probability to get at least 2 heads, that means more or greater or equal to heads, then what we need, we need to include 3 heads as well, and that will be 4 out of 8 or 1/2. Make sense?
Yeah.
Now, that's how the tree diagram works. If we have the probability of each outcome is the same, 1/2, 1/2, 1/2. But what if the probability is not the same? Example. Let's say Ashton in his drawer has he has socks. He has 5 white socks and he has 8
Orange socks.
black socks and he has 3 red socks.
Yeah.
And he has 3 red socks. So
Is this
when he
Wait, like
take one sock at random, he can get white, he can get black, he can get red. But the probabilities are not the same.
Yeah.
How many socks he has altogether?
16.
16.
Good adding up.
So what's the probability of get white sock?
5 out of 16.
5 out of 16. What's the probability of get black sock?
8 out of
1/2. 8 out of 16 or 1/2. What's the probability of get red sock?
3 out of
3 out of 16. Red, so we have 3 out of 16. Now, if he put it back, he put that sock back and take again another one at random. So here again they get white, black, and red, white, black, and
But
red.
you put it back, right?
He put it back.
Wow.
He put it back, so probabilities remain the
Yes,
same. If you will not put it back, probabilities will
Then
change.
it's out of 15.
So we will have white,
No, 15.
black, red, so we have same probabilities. 5 out of 16, 1/2. Red is 3 out of 16. White 5/16. Black 1/2. 3 out of 16. 5, 6. 1/2. 3 out of 16. So what possible outcomes he can get? He can get 2 white socks. He can get white and black, white and red, white and black, white and red, black and white, black and black,
It's not blue.
black and red, red white, red black, red and red. But what will be probability of get 2 white socks? Any ideas?
5 minus
6, 7, 8, 9, 15, 10.
32, 1 out of 32.
What?
Oh, wait, what was the question?
9.
What the probability
Five
of
over
get
32.
2 white
1
socks?
out of 32.
Can you multiply this?
Five
1 out of 9.
1 out of 9.
This-
1 out of 9.
multiply this.
Because that's 9.
It's out of
There's 9
No.
sets.
36.
We need to multiply
I knew it.
those probabilities. So that will be 5 out of 16
Oh.
times 5 out of 16. So it will be 25 over
30.
256, I think. Will be 256, yeah. 256. So that will be probability of get 2 white socks. What the probability of get 2 red socks?
Pretty low.
3 over
3 over
16.
16
3
times 2
16
16
times
9
3
over
16.
256.
9 out of 256.
Ow!
What will be
Don't hit Ashton. I mean,
what will be the probability of get white and black? 1 white, 1 black. What we have here?
5 over
Two.
16
It
times.
is black and white
Times
as well.
1/2
Yeah, but
equal 5 out of 32. But we can get black first, then white. So again, we'll have 1/2 times 5 out of 16 equal 5 over 32.
Wait, why is that 5 over 16?
16. It's 16 here. So, but in both of those cases, we get 1 black, 1 white. So what we need to do for black and white, we add them together, and we get 10 out of 32, which simplifies to 5/16. Because
How come we just do that?
he get here it's white and black, here black and white. So he get 1 black, 1 white.
We did
Right?
white double.
It's the same thing, doesn't matter in which order.
oh.
Plus
You get black and white or white and black.
Okay.
Each of these outcomes has probability 5 out of 32.
What the hell?
But in both cases we get 1 black, 1 white. So we add those probabilities
Same thing.
because it's the same thing, 1 black, 1 white.
I get it.
Okay, that's what we're learning new for today. Like, subscribe and donate to help Ukraine to beat Russian fascists.